Physical models are tangible representations of objects or systems, often used to simplify complex concepts. By using everyday materials, you can create models that illustrate real world phenomena, such as a toy car representing a real car's mechanics. These models help in visualizing and understanding the underlying principles they represent. Toy cars and doll houses are scaled down versions of real objects. They help us understand the structure and function of their full size counterparts. While a toy car lacks a real engine, it still represents the car's shape and design. Similarly, a dollhouse mimics the layout of a real house, aiding in visualization and comprehension. Models are essential for visualizing complex ideas. Just as a miniature playground helps convey design concepts, scientists use models to study phenomena that are too large, small, or intricate. These models simplify understanding and allow for experimentation without the constraints of real world scale or complexity. A physical model is a three-dimensional representation with length, width, and height. It allows you to touch and view it from various angles. These models are copies of real objects, often scaled differently and constructed from diverse materials, providing a tangible way to study complex structures. Scientists use physical models to visualize the unseeable, like plant cells or mountains. These models help understand how parts fit together, such as in molecules or volcanoes. Engineers test ideas safely using scale models of buildings and bridges to assess their resilience to strong winds or earthquakes before actual construction. Physical models are tangible objects you can touch, representing real objects or ideas. They aren't the actual objects, but help us understand them better. By providing a hands on experience, these models bridge the gap between abstract concepts and real world understanding, enhancing our grasp of complex subjects. Consider a globe at home, a tangible model of Earth illustrating continents and oceans. In schools, skeleton models help students learn bone structures without needing a real skeleton. In the Philippines, architects use building models to visualize new constructions like malls, providing a preview before actual building begins. A physical model acts as a three-dimensional representation of a real object, aiding in the study of things not easily visible. While not the actual object, it enhances understanding. Building a model creatively expresses your ideas, making complex concepts tangible and easier to grasp. A plant cell is microscopic, so we use a model to study its parts. Use a clear plastic box for the cell wall, green clay for chloroplasts, a small balloon for the nucleus, and water with yellow food coloring for cytoplasm. This model helps visualize and understand the cell's structure. A water molecule consists of two hydrogen atoms and one oxygen atom. Using two small white pom poms for hydrogen and a larger red pom pom for oxygen, connect them with pipe cleaners or glue. This model illustrates the basic structure of a water molecule, aiding in understanding its unique properties. A common misconception is that models are mere toys. Unlike toys, scientific models serve a purpose. They help us learn, explain, or test real world ideas. Another mistake is thinking models must be perfect replicas. In reality, models simplify by highlighting essential features, like a solar system model focusing on main planets, not every space rock. A good model should be simple, sturdy, and show the structure of the real object. Remember, if it's in my hand, I understand. Physical models simplify complex ideas, making them easier to grasp. This approach aids in learning and understanding intricate concepts effectively. Scientists have long used physical models to innovate. The Wright brothers, for instance, built small model gliders to understand wing mechanics before creating the Wright Flyer. These models were crucial in developing their groundbreaking flying machine, demonstrating the power of models in scientific advancement. Following a recipe is like using a model. The recipe is your plan, and the dish is the final product. Similarly, explaining complex ideas like your school's layout can be simplified with a map or a 3D model, making it easier for others to grasp. A physical model is a three-dimensional representation of a real object or system. Scientists use these models to study entities that are too large, small, or complex. Creating a model aids in understanding and explaining functionality. Examples include globes, skeleton models, and architectural building plans. Engage in science projects by creating models to explain concepts. Grasp architectural practices by understanding the use of miniature buildings in presentations. Express your ideas by building models of complex concepts like a dream treehouse, which are challenging to convey with words alone.